Hi everyone, and thank you for joining me for some virtual vitamin Z as we bring the Detroit Zoo to you. My name is Claire and I'm a curator of education with the Detroit Zoological Society, where we are celebrating and saving wildlife. And if you joined us on Tuesday morning, we posed a design challenge to you. We talked about a real world problem and how it was affecting wildlife, and asked all of you to come up and design some solutions on how we could help animals. So today we're going to go over the submissions that you all sent in, and I have to say I'm so impressed. You came up with some amazing ideas for me to share with the animal wildlife rescue team down in the Amazon. And we're also going to talk a little bit about what makes something sink versus float and how that all works. So let's look at a little bit of vocabulary that we're going to need to have that conversation. We're going to talk about density, buoyancy, and molecules. All right, so let's start with a little recap of where we were on Tuesday. So on Tuesday, we went down to the Amazon rainforest, where the Detroit Zoological Society has been working for more than 2 decades on a variety of different conservation projects. And we looked at the seasonal changes that happen in the rainforest ecosystem. And animals, plants, and people have all kind of adapted to those different changes. And some of those adaptations look like building your houses up on stilts, so when the waters come in, the water can go underneath the houses and they can continue to live in them. And just to show you how much that water changes from November, October, when the water's way out in the river, and you can see this is a whole big soccer field for the staff to play soccer on, versus in April, May, March, April, May, where the water rises and the river starts to flood into the rainforest, and it changes quite a bit. So as those floodwaters come up, they can create these little islands and these pockets of land. And sometimes that can happen really fast, even overnight. So we challenged all of you to design some sort of a floating structure that would help get animals off of the island and back to the mainland. So to do that, we had to start thinking about, well, what floats and what sinks? So one of our viewers sent in their test samples of what floats and what sinks. And you can see these 2 rocks sank right down to the bottom of their bucket. But all these things floated: the seed pod, the wood chips, the hollow stem from a plant. So what does make something sink? And what makes something float? Let's look at it a little bit closer. So everything around us is made up of molecules. And sometimes the molecules are really far apart, like in the gases in the air that we breathe. And sometimes they're really dense, like in hard objects. Those molecules are packed together really, really closely. So to demonstrate this, I have an Easter egg, and it's empty on the inside, so it's not very dense. Those molecules on the inside are moving around and there's a lot of space between them. So if I close up this Easter egg and tip you down a little bit so you can see my bowl of water, if I put it in here, that Easter egg is going to float. So the water's pushing up with some buoyancy, the Easter egg's pushing down, but the Easter egg's not pushing down hard enough to sink down to the bottom of the water. Now, here's another Easter egg, and it's empty right here, but there's my sand, I almost lost it. If I fill my sand up, if I fill my egg up with sand, I'm making it a lot more dense on the inside. There's not as much space anymore. Those molecules are packed together really tightly. So let's see if I can get this closed. Now if I put this egg, it's the exact same shape and size, but it's a lot more dense inside, which means when I put it in the water, it's going to push more water out of the way, and the water might not have enough buoyancy to push it back up. Let's try. Right down to the bottom. So because I changed the density of that object, I made it sink. The water couldn't push up enough. And I have one other way to show you how this works. Here's some Play-Doh. And if I take this Play-Doh in the shape that it is, it's very dense. It's all squished together, and it's not going to displace a whole bunch of water. It's just going to boop, sink right down to the bottom of my bowl. But if I take it out, and just a word, Play-Doh tends to get a little slimy after you put it in the water, and I squish it out so it's going to displace more water. I'm going to make it a little bit of a cup shape here. And when I put it back in the water, we'll see if I've spread it out enough that it displaces enough water that the water can push back up and have it float. And there it goes. Now it's floating instead of sinking straight down to the bottom. So that's how the density of something changes whether or not it sinks or floats. So now that we looked at that, let's bring you back up so you can see some of the incredible rafts that you all made to make sure that our animals are going to get off those islands and across and back to the mainland in the rainforest. So here is step 2 of our challenge. I challenged you all to make a raft or some floating structure that had to float for at least 30 seconds to get those animals off the island. Bandit sent me pictures of his whole design process. So he cut up a bunch of strips, he wove them together, he made a little pool on the top to hold the animals, and then he tested it, and it floated for 30 seconds. So now that it floats for 30 seconds, the next part of the challenge was to see how many animals you could get off the island. So for every quarter, that equals a tapir, every penny equals a monkey, and every dime equals 10 frogs. And just as a reminder, tapirs are really important. They live down on the bottom of the rainforest, and they eat a lot of seeds and a lot of plants, and then they poop that stuff out, and they spread rainforest plants all over the rainforest so they can grow in new places. Monkeys do the same thing, but they go up in the canopy of the rainforest, and they eat those seeds and those fruits, and they poop them out, and they spread a lot of seeds that way. So it's important that they get back to the mainland too. And amphibians, or frogs, they're really important for insect control. So they eat a lot of insects that can carry diseases and or are just bothersome to animals and humans. So it's important that we get those animals back into the rainforest ecosystem too. So here's Bandit's raft. Bandit was able to put 15 pennies in his raft, which equals 15 monkeys. So Bandit, well done. You rescued 15 monkeys off of our Amazon island. Sandy went for displacing a whole bunch of water over a big surface area, and she was able to rescue 6 tapirs, which is 6 quarters worth. The Aloha Express, this is made out of the tops of a pineapple, those little green shoots that come off the top of pineapples, and they actually use safety pins to put them together, which I thought was pretty clever. And you can see here that it's floating, so it passed our float test, and it was buoyant enough to hold 3 pennies, which equals 3 monkeys. We have Jesse's Tapir Saver, which is made out of cardboard, and it displaced enough water that the water was able to push up on it, and he was able to rescue 14 tapirs. That's a lot. We have Emily's raft, and you can recognize maybe those hollow sticks. So we know that they're not very dense, so they float and they're very buoyant. And because of that, she was able to pile on all of these coins. So she rescued 2 tapirs, 16 monkeys, and 10 frogs. This is Erin's raft. She made it out of a piece of bark, and it displaced enough water that she was able to rescue 4 monkeys and 20 frogs. This is Anne's barge, again another piece of wood, rescuing 4 tapirs, 3 monkeys, and 20 frogs. This is Fantastic Mr. Fox's raft. This one was made out of the top of a reusable carryout container, and it spread out all that weight over a large surface area of water, and it displaced enough water that the water is able to push up and support 5 tapirs, 4 monkeys, and 20 frogs. Quentin is a 3rd grader in Detroit Public Schools, and he took this challenge to heart, and he made a really neat boat out of paper that floated in his sink, and he was able to rescue 3 monkeys and 20 frogs, and he's after my own heart by rescuing all those frogs. They're such an important part of the ecosystem. Quentin, I'm so impressed with your design. Well done, sir. This is Naima's raft. She was our first person to send in a raft that had been done. She managed to make this in just a matter of a couple hours, so she works really fast and really hard. She was able to rescue a tapir, a monkey, and 10 frogs with her design. She folded it out in paper, and again, she has a little lip on there to hold all those animals inside, and she was able to float that and keep it floating. So well done, Naima. You did a great job, and you worked so fast and hard. I'm so impressed. Madison actually sent me a video of her raft. So she was able to save a tapir, a monkey, and 10 frogs. And I'm going to play this for you. Here she is. She's putting it in her sink. And you can tell that she spent a lot of time on this raft. And she put a little box around the coins to make sure that the animals wouldn't fall off on the raft, which I thought was really smart. Now you might be able to hear it, but she's counting in the background to make sure that her raft is going to float for 30 seconds, which was part of the design challenge. I also like that she had someone in the background who sounds like they might be younger than her counting along. Madison, you did such a good job on your raft, and I'm so impressed. Madison and Naima are also 3rd graders in Detroit Public Schools. I feel really good knowing that we have so many talented engineers growing up in our community. I feel really good knowing that you're going to be working on solutions later in life. All right. So thank you to everybody who turned in a raft submission so I could share out all of your amazing designs. An important part of that engineering process is being able to share your design and your thoughts and your ideas with other people so they can be implemented and expanded upon. And I want to give a special shout out to those 3 third graders who did such a fantastic job making your rafts and sharing them. Well done, you guys. All right, so thanks for participating today. I hope you're leaving with a little bit of a better understanding about what makes some things sink and some things float. It all has to do with that density and how closely things are packed together. Because if you think about it, huge barges go down the river, right? And while they're really heavy, they displace enough water that the water can push up and keep them floating down. So thank you again for participating. I love seeing all of the rafts that you came up with. If you tune back in today at 2 o'clock and 4 o'clock, my colleagues Sandy and Zara will be sharing more information about animals that live at the Detroit Zoo. And thank you. Until then, stay safe and take care of each other.